Alright guys, welcome to Math 0314, section 7.2, Quadratic Formula. So today we're going to talk about the famous quadratic formula. But first, let's look at question number 1, and let's see if we can figure out what to do here. So the question here is asking us, how do we solve for 2x squared minus 3x equals 5, figure out what x is equal to. So standard protocol is to move the 5 to the other side, and when I do that, I want to try to factor this. So I will sit here and I will say 2x and x, because 2x times x is 2x squared. Then I'll go to the back and I'll say 1 and 5 in an attempt to get to 3. And let's see here. So if we look at this, we'll get 2x and we'll get 5x. And because 2 minus 5 is negative 3x, if I make 2 positive and 5 negative, this thing is factorable. And so we can take each component and set it equal to 0 and solve and get x to be 5 over 2 and x to equal negative 1. And at this point in the video, in this course rather, you should be able to see that at this point. Okay? This is what we did in by the end of chapter 4. Now, we've learned another method recently. In the last video, we learned a different way to approach this. And so here's the original problem, sorry. And the way we did it is we started it off, well, we could start off by doing the same thing we did last time, but what we did is we divided through by 2 to create a leading coefficient of 1. And so this would be x squared minus 3x over 2 equals 5 over 2. And this is called completing the square. And so why we do this is that if I take, let me rewrite this, x squared minus 3 over 2x, give myself a little space and put 5 over 2. So what we say is we take this value and we divide by 2, which just means you multiply the denominator by 2, and square it, we get, now this is 4, right? Let me change this to a 4. So this is 4, this will become negative, so we're going to square negative 3 over 4. And when you square that, you end up getting 9 over 16. So you get plus 9 over 16 plus 9 over 16. Because the reason why we have to add to both sides is that in actuality, all I did was I added 9 over 16 to one side, so to balance the equation, I have to add it to the other. But the reason why we like this is if we do this, this whole part here is just x minus 3 over 4. This part, what was generated here, squared. To clean this one up, I'm going to multiply by 8 over 8, so this is going to be 40 plus 9, and the bottom part of 16. So this is 49 over 16, just 40 plus 9 is 49, and the bottom is 16. And the reason why we like this is that we can take the square root now, and when I take the square root of this, we get x minus 3/4 equals to, now look at, this is cooked up to be nice, so this is going to become, square root of 49 is 7, square root of 16 is 4, and this of course is plus or minus. So I have two situations here. I can either say x minus 3/4 equals 7/4, or I can say x minus 3/4 equals negative 7/4. This is, I'm at the end of the page. I want to finish this. See if I can finish it off on this page here. So if I solve this one, I would add 3 over, it would get 10 over 4, which is, so x equals 10 over 4. Hopefully you see that. I'm just adding 3/4. Sorry, I'm squeezing this in. You get 10 over 4. And 10 over 4 reduces to 5 over 2. On this side, we're going to add 3/4. And I get negative 4 over 4, which is negative 1. So we're getting 5 halves and negative 1. Let's see. Look at that. 5 halves and negative 1. So they match up. So this was another way of doing it, right? Is completing the square. Now, what completing the square boils down to is another process that we're going to talk about today. So let me actually rewrite this again. I ran out of space. Didn't think I was going to use that much. That's okay. So let me write the problem again. 2x squared minus 3x equals 5. And this is the quadratic formula. And in another video, I'm not going to show it here, but in another video I'll show you how the quadratic formula really is nothing more than completing the square. But first what we want to do again is just like we did before, so we want to subtract 5 from both sides. And we'll get 2x squared minus 3x minus 5 equals 0. So the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a, given something in the format of ax squared plus bx plus c equals 0. So what you can see here is that a goes with 2, negative 3 goes with b, negative 5 goes with c. And all we have to do is substitute in this value and it will produce the results. So let's do that. So if we plug in a, we said a is 2, b is negative 3, and c is negative 5. And how you want to substitute into this formula is your discretion. Some people like to, they can look at the equation and they can just substitute in. Some people like to write what the letters are and then substitute in. It's up to you how you want to do it. I think if you're one of these people that tends to overlook things, rewriting what A, B, and C are helps you to be clear. The big thing that I think you should be conscious of are the negative signs. I think that's the common mistake that students make. So let's substitute in. So it's going to be negative b. So negative, what's b? B is negative 3. So notice you have negative 3 plus or minus square root b squared. So I'm going to put negative 3 squared minus 4. A is 2. C is negative 5. All over 2a. And of course a is 2. And we're just going to continue playing with this. So continue breaking this down. Negative becomes a positive, so this is 3 plus or minus square root. Negative 3 squared is 9. What I like to do is play with the sign, so negative becomes a positive. And I'm always looking for the fastest way to do this, so I'm going to actually do 2 times 5, which is 10. 10 times 4 is 40. Makes it easier. And this is over 4. And this breaks down to 3 plus or minus square root 49 over 4. Notice that this 49, square root 49, is the same thing as this square root 49. And you can actually even see the 4 formulating in the bottom as well. And that should be happening. If you were to solve it, normally you wouldn't solve it in 3 different ways like I'm doing right now. But if you did, you should notice that similarity because, again, completing the square and the quadratic formula are essentially the same thing. So this breaks down to 3 plus or minus 7 over 4. And now this breaks off or siphons off into 2 scenarios. We have 3 plus 7 over 4, which we said looks strangely familiar from before. This breaks down to 5 over 2. The bottom we're going to have 3 minus 7 over 4, which is negative 4 over 4, which is negative 1. So we use the quadratic formula. This is familiar probably from high school. If you don't remember how to do it, you do remember it in some form or fashion, right? It's the classic high school formula that you use over and over again, and we like it because it's while it's a little bit ugly looking, it does help you to solve a lot of fancy problems. And eventually, what ends up happening is the first move that we did, this sort of factoring from chapter 4. This chapter 4 factoring that we did is nice in this, and you're probably sitting here wondering, like, Mr. Anderson, why don't I just do the first way? The other two are vastly more complicated. And the answer is that this method only works when the solutions come out nice. And a lot of times the solutions, actually, in the real world, the solutions seldomly come out nice. Most of the time they come out pretty ugly looking, like we'll see shortly. But if this method doesn't work, then you really want to jump into these other 2 methods. And while the completing the square is the same thing as the quadratic formula, we can see that the quadratic formula really takes, the quadratic formula takes a little bit less time, and it's a little bit more organized, I think. So we're going to want to notice the catch to playing with the quadratic formula, which we're about to do, is that you do need to know the formula. Now, in high school, they teach a little song related to this, so I'm gonna sing this song and see if it helps you. It goes something like this: x, because this is always x, right? This is equal to x. This is what x is equal to. So the song goes something like this: x equals negative b plus or minus square root b squared minus 4ac all over 2a. So if that helps you to memorize it, go ahead. Hopefully listening to me is not singing is not something that you're going to have to keep getting used to, because, well, we all know that my career as a pop singer is not very long. Okay, alright, so that was attempted humor. Let's keep going. Number 2. So here I want you to actually solve this by using the quadratic formula. So if you haven't done so already, pause the video, try it on your own. Otherwise, let's do it together. So I'm going to assume that you've tried it on your own. They're trying to intimidate you by having parentheses, but you're going to distribute. So we're going to get negative x squared plus 6x equals 11. Now, we have some options to do of what to do here. I'm actually going to do something a little interesting. I'm going to add x squared and then subtract 6x over. In other words, I'm going to move both the x values to the other side. And the reason I'm going to do that is because I like for this leading coefficient to be positive. It's just a preference of mine. It does not have to be that way. You don't have to have that to happen. So this is now in standard form, so I know a is 1. Remember, a is the number in front of x squared. B is negative 6. That's the number in front of x. And the number by itself, or the constant, is c, which is 11. So the quadratic formula, and I encourage you to write it out every single time, because the more you write it out, the more it'll start to memorize. The more you'll start to naturally memorize it. And I think that's the best way to get it in your head, is just writing it out over and over and over again and just naturally memorizing it. Okay, so now we're going to just plug in. So I know b is negative 6, so it's going to be negative 6 plus or minus square root negative 6 squared minus 4ac, c is 11, all over 2a, a is 1, and we're going to get 6 plus or minus square root 36 minus 4, because a and c, well, look at me, can't read my own handwriting, that's 11, so this should be 44 rather, all over 2. Now, this is very interesting, because what we're going to get now is, if we clean up the inside, we're going to get square root of negative 8. And this is an imaginary value. So this becomes 6 plus or minus, we'll put an I on the outside, because we know the square root of negative 1 is I. We learned this at the end of chapter 6. This is 8 over 2. Now, we can break the square root of 8 down as well. This becomes 6 plus or minus 8 is 4 times 2, so this becomes 6 plus or minus, we like to write it this way, 2i square root 2. The square root of 4 becomes 2. This is all over 2. And there's one more move that we have left, which is that because both of these are divisible by 2, we can divide the whole thing by 2. So this becomes 3 plus or minus I square root 2. If both of these were not divisible by 2, we would have stopped at this step. But because they both are, we stop here. And this is appropriate. We can leave it as 3 plus or minus I square root of 2. This means 3 plus I square root of 2 and 3 minus I square root of 2. But it's appropriate to leave it as plus or minus. This is a common notation in mathematics. So there you have it. It's just plugging and chugging and getting your answer. Okay. Now, we're going to talk about now something called the discriminant. And the discriminant, actually let me go onto a blank page here. The discriminant is the inside portion you can hear me pausing because I'm going negative b plus or minus square root b squared minus 4ac. But this portion right here, the radicand inside the quadratic formula, this is the discriminant. This is what the discriminant is. And what the discriminant tells you is the number of solutions you have. And if you think about it, it makes sense, right? Because if b squared minus 4ac is positive, right? If it's greater than 0, you're going to have 2 solutions. And before I tell you, ask yourself, why does that make sense? And what I hope you realize is that because you're going to have a square root inside, if it's plus or minus, the plus or minus means you have 2 solutions, right? And these 2 solutions are going to be real solutions, right? The two solutions, plural, are going to be real solutions. They're going to be real numbers, right? Well, then the question is, well, then how do I get to imaginary solutions? And you probably know the answer to this, and I hope what you're saying is that's when b squared minus 4ac is less than 0. Because if it's less than 0, you're taking the square root of a negative value. And by taking the square root of a negative value, you get an imaginary solution. Well, there's one more scenario, right? We have greater than 0, less than 0. Well, what if it is 0? What if it equals 0? What happens then? What are the solutions? Well, if this is equal to 0, this whole part becomes 0. Then you're taking the square root of 0, which is 0. And all you're left with, this thing just breaks down to negative b over 2a. And negative b over 2a means that you have 1 solution. This solution is going to be a real number as well, right? But you're literally getting negative b over 2a, and that'll become your solution. So we like the discriminant because it's a quick, easy way for us to figure out the amount of solutions that we have. So let's see here. Let's go back to the problem. So it says use the discriminant to determine the type, and the number of solutions. So the quadratic form is negative b plus or minus square root b squared minus 4ac all over 2a. I only care about b squared minus 4ac, so b is negative 5, a is 2, and c is 9. So let's plug that in. So we have negative 5 squared minus 4, a is 2, c is 9. We're going to solve this 25 minus, now let's see what's the fastest way to do this. I think that's 36. 36 times 2 is 72. And I don't actually have to do 72 minus 25. I will to make you happy. This is going to give me 12. This is what, 7. We're going to bar here, 6. That's 4. If I add back 12, 6, 7, yeah, 72. So this is going to give me negative 47. But because this is negative, we said when it's negative, right? When it's negative, you have this scenario where you have 2 imaginary solutions. So this is going to be 2 imaginary solutions. And that's it. Okay, so go ahead, pause the video, try this one out on your own. Going to assume that you've done so. Now we're going to do it together. So hopefully your instincts were to move both the x and the 2 to the other side. And this will give me 3x squared minus x plus 2 equals 0. And again, the quadratic form is negative b plus or minus square root b squared minus 4ac all over 2a. B squared minus 4ac is the discriminant. And so what we're going to do now is we know that a is 3, b, remember, is negative 1, there's a 1 there, and c is 2. And so what we have here is we have negative 1 squared minus 4, a is 3, c is 2. So we have 1 minus, this is what, 12, 2 is 24, so this is negative 23. Interestingly, the last one was, I was seeing if I made a mistake or something. They're both the same, so this is another situation where you have two imaginary solutions. Interesting. Okay, so here's another scenario. So if you haven't done so already, go ahead and pause the video, try it on your own. I'm going to assume you've done that. Again, what we're going to do is we're going to distribute first. So negative 4x squared, remember x and x is giving me x squared, and then we distribute to the other side, we're going to have 6x, positive 6, negative times a negative is a positive, so positive 6x equals negative 1. Again, here I'm going to do something that I did earlier. I'm going to add 4x squared and subtract 6x to both sides. So I get 0 equals 4x squared minus 6x equals negative 1. This is just because I like a to be positive. If you did something different, that's perfectly fine as well. So a is 4, b is negative 6, and c is negative 1. The quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. And once more, hopefully I'm starting to sound like a broken record, I only care about b squared minus 4ac. So this is negative 6 squared minus 4. A is 4, and C is negative 1. The mind works faster than the hand. So once again, we're going to clean this up. Negative 6 squared is going to become 36. This is nice because we have two negatives, which makes it positive, and we get 16. So we already know we don't actually even need to solve it all the way. I'm going to go ahead and do so, get 52. But we know we have two real solutions, because it worked out nice. So moving right along. This one is trying to scare you with the format, but I think you guys can figure it out. So go ahead and pause the video, try it out on your own. I'm going to assume that you've done so. If you don't like the decimals, since they're all the same amount, you can literally just move the number over 1, or the decimal place over 1, because they're all the same. But what I'm technically doing is multiplying by 10. If you multiply by 10, you get 36x squared equals negative 12x negative 1. And so that's just trying to intimidate you. Not really that big of a deal. Just move. As long as you move the decimal places over the same amount, you'll be fine. This gives me 36x squared plus 12x plus 1 equals 0. Again, quadratic formula is negative b, and I'm hoping that you guys write this out every single time like I'm doing, because it will help you to memorize it. But I only care about this portion here. So this is a, this is b, this is c. I'm cringing inside a little bit just because the numbers are going to get big, but we can handle this. 12 squared minus 4a is 36. C, thank goodness, is 1. 12 squared is 144. That's a common one that people memorize. So this is 144. 4 times 36. I don't think many people know what 4 times 36 is, but 2 times 36 is a little more common. That's 72. And if you double that, you get 144 times 1. Oh, look at that. It's the one situation we haven't seen before yet. We get to equal to 0. This means we only have one solution. Remember, the reason why that's true is the square root. If this is 0, you're just left with negative b over 2a. So the solution is negative b over 2a. Again, and also what I really recommend, especially if you're going to go on to future math courses, is understand why it's true. Don't memorize. You could sit here and be like, oh, Mr. Anderson just blah 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 talked about this, but I got to these solutions. I got to these values. I just need to memorize these and spit it back out on a test and then move on with life. But the truth is, you don't want to do this, especially in a math class, because all of these ideas build on themselves. So if you're especially if you're planning to move on to another course, you really want to understand why it's true. Personally, I find it, I'm just lazy. I rather understand than know, because then I don't have to memorize anything. Memorizing is boring and difficult. I don't want to pound something into my head if I don't need to. Okay, so with that being said, the next part of the discussion is find the discriminant and use it to determine if there are x-intercepts. B is to find the x-intercepts, and C is to find the y-intercept. So I'm running a little short on time. I got about 5 minutes left, but I think I have enough time to do the first one. So they're asking us to, remember A is 1 here, they're going to ask us to use the discriminant to figure out the number of solutions first. So if this is true, remember the quadratic form is negative b plus or minus square root b squared minus 4ac all over 2a. See, you want to sing it, I know. All right, so we're going to plug it in, negative 3. Oh, look at me. You know, I am just going to directly plug it in. It's asking us to figure out the number of solutions, but since it's asking us to figure out, the number of solutions, which is the discriminant, and then it's asking us to find the solutions. So it's kind of a redundant question. When I solve this portion right here, that is going to tell me the number of solutions, but then I have to solve the whole thing anyways, so I might as well just solve the whole thing anyway. So this is 3 plus or minus square root 9 minus 5 over 2. So at this point, you can tell that the number of solutions, because you get plus or minus the square root of 5, that you have 2 solutions. So you have 2 real solutions. And this is about as far as I actually can go. So this is the answer. Now the other question it's asking is to find the y-intercept. And this is very interesting. So I've been trying not to graph this, but I kind of need to. So when we get 3 plus or minus square root 5 over 2, what this is saying, if this is my picture, a quadratic, let me look at this quadratic. A quadratic is going to, actually let me look at it again, is going to do something like, let me think for a second here. Yeah. It's going to go something like this. It's going to cross somewhere here. And then these two values are going to be 3 plus square root 5 over 2. And this one's going to be 3 minus square root 5 over 2. The reason why I was pausing is I had to figure out what the square root of 5 is. And so what I realized is the square root of 4 is 2. The square root of 9 is 3. So this is like 2 and some change. So 3 minus 2 and some change is going to still leave me with a positive result. That's what I was concerned with. In any case, this is what my picture is going to look like. And these values are the x-intercepts. These are the solution. The solution are the x-intercepts. Remember what we said a long time ago was if you're looking for the x-intercepts, you set y, f of x, which is y, equal to 0, and you solve, right? So that's why we started, when it says find the x-intercepts, I jumped straight to the quadratic formula because it's equal to 0. The y-intercept is going to be when what happens? Well, the y-intercept is when x is equal to 0. So what ends up happening is the constant, and this is always true, the constant is always the y-intercept. And that's something nice. It's almost like, remember when we talked about the y equals mx plus b, for a linear equation, we said b is the y-intercept. Now the letters is confusing because b here is negative 3, right? But what I'm saying is b represents the constant, and that is the same thing here, where 1 is the constant, and that is the y-intercept. So we still have some problems. We have this one here, and then we have these problems at the very end to work through. Oh, that's it. So I'm going to solve these in the next video. This one is asking us to do the same thing, find the discriminant, determine the number of solutions, x-intercept, y-intercept. This is just these last ones are just asking us to solve for x. So I will solve these in the next video, but you should be able to do these on your own, and I hope you do so. You try to do it on your own. In any case, hopefully this wasn't too bad, and I'll see you on the next math video.